Okay, so which gas law would you use to solve this problem? If a pressure exerted by a gas at 25 degrees Celsius in a volume of 44 milliliters is 3.8 atmospheres, how many moles of gas are present? Well, that last part of the question, how many moles of gas, is significant. It means that the only gas law that I can use to solve this problem is the ideal gas law, because it's the only one that deals with moles. So I'll be using the ideal gas law, which is PV equals nRT. The P stands for pressure, the V stands for volume, the N stands for number of moles. The R is a reference number. It's the constant for the ideal gas law, and it has to be provided to you because we're not making you memorize those. And T is temperature. Now there's some significant aspects to this problem. P can be in any unit. V must be in liters. N will come out in moles. R is a pressure constant that has to do with the pressure, so it is specific to that pressure. And temperature has to be in Kelvin. So let's look at our problem. If the pressure exerted by a gas in 25 degrees Celsius, so 25 degrees Celsius, the first thing I have to remember to do is 25 degrees Celsius isn't in the needed Kelvin. So I would need to do 25 plus 273, because if you have C, add 273. So my temperature for this problem is 298 degrees Kelvin. The volume is 44 milliliters. That's not in the proper units of liters. To convert from milliliters to liters, you just simply move your decimal points 3 places. 1, 2, 3. So it would equal 0.044 liters in the proper units. I can use atmospheres, and so now I can set my problem up PV equals nRT. The R value that's necessary for atmospheres is 0.0821. So this is my pressure in atmospheres, P. This is my volume in liters, V. This is my unknown. This is my R value constant, and this is my temperature in Kelvin. When I isolate my variable, I get 3.81 times 0.44 liters divided by 0.0821 times 298 Kelvin. It's important to remember when you have two numbers on the bottom when you're dividing that those numbers be in parentheses. When I solve for X, my answer is 0.0069 moles.